Hello and welcome to AI-generated QA coverage derived from business requirements, where we take a trading platform's onboarding and eligibility acceptance criteria and let ChatGPT turn them into traceable, runnable tests. Hello, I'm Scott, and I've spent about 7 years in QA automation, much of it in financial institutions. And today I want to show a realistic slice of day-to-day work involving generative AI. We'll take a business analyst requests of a clear user story with acceptance criteria and then have AI generate the QA testing strategy around it. Test plan, positive, negative scenarios, all the pieces. The goal is to show how I use AI to go from BA to testable requirements. If that sounds like your world, you're in the right place. Right now, my fictitious trading platform knows who the client is, their ID, their legal name, domicile, and products. But it doesn't know whether they should be allowed to trade, what, how, or through which channel. That missing context lives in external spreadsheets and emails, KYC risk, regulatory classification, ISDA, International Swaps and Derivatives Association, margin and connectivity. The result is manual checks, inconsistent limits, audit gaps, and higher operational risk when we're onboarding under time pressure. The fix is simple and powerful. Make a client master file that will be the single source of truth by adding 6 system fields: regulatory classification, KYC risk, onboarding status, ISDA signed, margin agreement, and connectivity. These fields let platform enforce rules automatically. Only approved clients can trade. Derivatives require ISDA plus margin. Orders are only allowed over approved connectivity: GUI, FIX, DMA, API, and COLO. Business value: 1. Well built-in regulatory suitability. 2. Automated trade control, pre-trade controls. 3. Fewer spreadsheets and faster onboarding. 4. Clean auditability. Why was this trade allowed? Is visible on one screen. User story. As an onboarding analyst, I capture and maintain those attributes, so eligibility and connectivity are enforced automatically with a single auditable source of truth. That's our North Star. AC1 and AC2, data plus quality. First, we prove the data contract. ACI, the 6 fields are present and create/edit and persist correctly. AC2, only valid values are accepted. Type pick lists for each field and control multi-select for connectivity, so downstream rules read clean data. AC3 to AC6, enforcement and visibility. Then we prove the controls. AC3, onboarding status is the primary gate. Only approved can trade. AC4 and 5, derivatives and leverage products require ISDA and margin respectively. Cash products don't. AC6, risk, compliance and sales get a read-only details page showing exactly why a client can or cannot trade. I'll walk through the acceptance tests and show how AI helps generate realistic scenarios that exercise every branch of the logic. I fed the user story and acceptance into an AI prompt, ChatGPT in this case, and asked it to 1. Extract the decision logic, 2. Enumerate the states of each field, and 3. Propose tests that hit the allow/deny branches. The model distilled the rules to a simple predicate: approved and cash or ISDA plus margin, and channel and connectivity, then generated a matrix that covers positive paths, for example, approved plus ISDA plus margin on derivatives. Next, negatives for every gate: non-approved, no ISDA, no margin, wrong channel. Boundary/data quality checks for all enums, plus multi-select combinations for connectivity, and realistic edge cases like mixed product strings and audit logging. My role was to check for defects in the AI generated testing. Net effect, we go from hours of manual test design to minutes of review with cleaner coverage and fewer blind spots. Background. The trading platform division currently stores only basic information about trading clients, client ID, legal name, domicile, and products. Risk compliance and operations teams maintain additional information in spreadsheets and email, for example, know your customer risk rating, regulatory classification, ISDA status. This leads to manual checks before enabling trading, inconsistent application of risk limits, audit and compliance gaps, no single source of truth, higher operational risk when new users are onboarded under time pressure. The proposal: extend the client master record in the trading platform to include the following new system fields: reg classification, regulatory client classification, for example, institutional, eligible contract participant, sovereign, KYC risk rating, low, medium, high, as assigned by compliance, onboarding status, life cycle status, pending, in review, approved, rejected, ISDA signed. ISDA, of course, refers to the International Swaps and Derivatives Association. Flag indicating presence of an executed ISDA master agreement, yes or no. Margin agreement, flag indicating whether a margin/CSA agreement is actually in place, yes, no again. Connectivity, approved connectivity options, GUI, fixed, DMA, API, Colo, multi-select. Existing fields like client ID, legal name, client type, products are already present. The business value of combining these data fields: 1. Regulatory compliance and suitability. Reg classification and KYC risk allow pre-trade controls to block products that are unsuitable for retail or high-risk clients. Supports Dodd-Frank local rules by embedding classification directly into the trading system. 2. Automated trading controls. Onboarding status can be enforced at order entry time. Only approved clients can trade. Pending/in review can be restricted to test environments only. ISDA signed and margin agreement control, where the derivatives and leverage products are allowed. Operational efficiency. Single source of truth. Onboarding, sales, and operations no longer maintain parallel spreadsheets. Connectivity drives automated provisioning, for example, fixed session versus GUI only. Risk management and auditability. Clear audit trails showing why a client was allowed to trade a given product, and easy evidence for regulators and internal audit. Show me all high-risk clients trading derivatives via DMA. That's the kind of inquiry that can be easily answered. So now we'll look at our user story, the user story from the BA that they've provided for us. So as a trading platform onboarding analyst, I want to capture and maintain regulatory, risk, and agreement attributes, being reg classification, KYC risk, onboarding status, ISDA signed, margin agreement, and connectivity on each client record. Currently, they're in 2 separate files, actually 2 to 3 separate files. So that trending eligibility and connectivity can be enforced automatically by the trading platform, and we have a single source of auditable truth. So in summary, as an onboarding analyst, I need to capture and maintain the regulatory, the risk, and the agreement attributes on each client so that the trading platform automatically enforces the eligibility and connectivity. We don't have to marry together different sources. And this happens because we have a single auditable source of truth, our North Star. Why this matters? What's the business value? Well, we reduce manual checks and inconsistent decisions when switching between the different spreadsheets. Eligibility becomes rules driven, fewer errors, faster onboarding. We create a single auditable record for compliance and investigations. What's in the scope? The attributes. Well, we've got reg classification, for example, institutional, professional, corporate, know your customer risk, KYC risk, low, medium, and high from a KYC review. Onboarding status, pending, in review, approved, rejected. ISTA signed, yes or no. Needed for the derivatives. Margin agreement, yes, no. Needed where a margin applies on trading. Connectivity, the allowed channels, GUI, fix, DMI, API, COLO. Core rules that we'll enforce. Here's an example. If onboarding status does not equal approved, that is, it is not approved, block all trading. If product is derivatives and ISTA signed equals no, we reject. There's no trading for that. If order channel not in connectivity list, we reject the trade. We prevent the session from being created. Margin required, product but margin agreement equals no, we reject that as well. Optional, you can escalate warnings when know your customer risk is high. This is enhanced monitoring. We won't be doing that in this example. Acceptance criteria 1 and 2. So this slide covers our first two acceptance criteria for create/edit fields. AC1 is simply about visibility. When an analyst creates or edits a client, the system must show the 6 new attributes: reg classification, KYC risk, onboarding status, ISTA signed, margin agreement, and connectivity. AC2 locks down data quality with strict pick lists. Each field only accepts approved values: reg classification, the regulated client types, MiFID, professional, institution, eligible, CP, professional investor, non-financial counterparty, wholesale client, corporate client, investment firm, pro, professional/institutional, sovereign or corporate counterparty. KYC risk, just simply low, medium or high. Onboarding status, pending, in review, approved or rejected. ISTA signed/margin agreement, yes/no. Connectivity, multi-select from GUI, fix, DMA, API or COLO. The takeaway here is that analysts can see and edit exactly what they need, and the system guarantees clean, standardized inputs that downstream eligibility and audit can trust. Now we move from data capture to rule enforcement when a client is allowed to trade. So these are the next acceptance criteria 3 through 6. So AC3, acceptance criteria 3, onboarding gate. Only clients with onboarding status that is equal to approved can place live orders. Pending, in review, rejected are all hard blocks. The platform must return a clear error that names the status. For example, blocked onboarding status equals pending. This gate fires first and stops everything else. Acceptance criteria 4, ISTA for derivatives. Now, if ISTA is signed equals no, the client cannot trade any derivatives. We detect derivatives by product taxonomy/keywords such as swaps, derivatives, futures, options. Cash products, for example, equities, bonds, spot FX, still pass if AC3 is satisfied. Edge case, mixed product strings. So this is a case where we have cash and derivative, but this must still be blocked. Acceptance criteria 5, margin for leveraged products. If margin agreement equals no, block anything that requires a margin. Futures, options, derivatives. For derivatives, both ISTA yes and margin yes are required. If either is no, the trade is rejected with the appropriate reason. AC6, audit and view. All these attributes must be visible on the read-only client details page, used by risk, compliance and sales, so that the rejections are explainable. This supports audits and gives front office a single source of truth. Now it's time to look at the tests, and these tests, of course, were generated by AI. So all the coverage is provided by AI, all the tests, all the explanations, the ID, the title, the preconditions, the steps, the expected, and it's a huge time saver. So let's have a look at what coverage has been provided to us. So this slide here is all about AC1, acceptance criteria 1, creating and editing fields. We're not testing the rules yet. We're just testing the UI and the persistence contract for the 6 attributes. So test AC 1.1, we're going to create a form that shows 6 fields. And when I open Create Client, I expect to see exactly these 6 fields: reg classification, KYC risk, onboarding status, ISTA signed, margin agreement, connectivity. This proves AC1 on the create path and catches mapping/visibility issues right up front. AC 1.2, test AC 1.2. Edit form shows existing values. Opening edit client must pre-populate the same 6 fields with the saved values. This validates the round trip from storage to UI. Still AC1, now on the edit path, and it surfaces migration and serialization mistakes. TCAC 1.3, save persist changes. Change each field and hit save. Reopen and verify the new values are there. This proves the right path for all 6 attributes and that multi-select connectivity persists correctly. In practice, I parameterize this so that we toggle each field individually and in combination, and I spot check via API/DB to avoid any UI cache illusions. Test AC 1.4. Cancel does not persist. Make edits, press cancel, reopen. The original values must still be present. That's right, the original values must still be there as we have cancelled the transaction. This protects against accidental writes and confirms we only commit on save. Now for coverage mapping, AC1 fields exist in create, edit and persist correctly, fully covered by TAC 1.1 through to TAC 1.4. So the takeaway here is that with these 4 tests, we lock down the basic contract. The 6 fields are always visible, editable, and correctly persisted, and we don't write on cancel. Then we layer validation AC2 and rule enforcement AC3 to AC5 on top of this. This slide here proves the first part of AC2 coverage. Will be a second slide covering the second half of AC2 coverage. These are the valid values only for 5 fields. There are 6, so this is the first 5. We're checking 2 things for each. 1, the UI only offers the allowed set, no extras, no typos. And 2, a selected value persists and reloads correctly. TAC 2.1, reg classification dropdown and persistence. We iterate to the full list, MIFID professional through corporate counterparty. For each one, select, save, reopen. Expectation, it reloads exactly as chosen and the drop down contains only the enumerated set. This catches mapping mistakes and missing options. TAC 2.2, KYC, know your customer risk, allows only low, medium, high. Same pattern, cycle low, medium and high, save and reopen. Assert the set is constrained to low, medium and high and the chosen value persists. This prevents free text or unexpected values like very high. Test AC 2.3. Onboarding status allows only pending / in review / approved / rejected. We verify the 4 statuses are present, nothing else, and each persists on reload. This is important because AC3 later enforces trading rules off of this field. Test AC 2.4. Is designed is strictly yes or no. Toggle yes, no, save, reopen. Assert there's no third state or null. This protects the downstream derivative rule, which is AC4. TAC 2.5, margin agreement is strictly yes / no, yes or no. Same toggle persist check for margin. Again, no third state. This underpins the leverage products rule, which is for AC5, acceptance criteria 5. Implementation note. I parameterize these single test and iterate the allowed values, and I double check the saved value via API/DB to avoid UI caching illusions. Now we'll recover the remaining AC2 items, connectivity, multi-select options / persistence, and the negative attempts to inject invalid values on the next slide. Together, AC 2.1 to 2.9 give us complete enumeration coverage for all 6 fields. Now we move on to acceptance criteria 2, tests and the continuation of them. We'll start with test AC 2.6, connectivity, single select. We validate each channel individually, GUI, fixed, DMA, API, and Colo. For each, select, save, then reopen. Expect exactly one value stored, no hidden defaults or extra flags. This catches mapping bugs like fix saving as GUI or a null write. Test AC 2.7, connectivity multi-select. Now we verify combinations, for example, GUI plus fix, fix plus DMA, GUI plus API plus colo. After save reopen, we assert the full set round trips. Order is irrelevant, and deselecting removes the item. This protects us from array order bugs and duplicate merge issues in the persistence layer. TAC 2.8, negative. Reject invalid enum multi-select. We attempt to sneak in values that shouldn't exist. For example, KYC risk, very high. Onboarding status, live. Connectivity, SFTP. Through UI and direct API. Expectation, save is blocked with a clear validation message. Nothing persists. This stops bad data poisoning the rules we enforce later from AC3 to AC5, AC7 and AC8. Test AC 2.9, hygiene, case white space, empty handling. We try inputs with case differences, leading, trailing spaces and blank values. Expectation, values are either normalized to the canonical enum, fix in small caps through to fix in full caps, or rejected per spec, never silently enforced to the wrong thing. This closes the door on subtle, looks like fine in UI, breaks in rules, defects. Why this matters? These 4 tests finish AC2 by locking down the allowed value space for the field that later drives connectivity enforcement, AC7 through AC8. If AC2 is tight, the trading rules read clean data and behave predictably. Acceptance criteria 3 tests, trading blocked unless onboarding status equals approved. What AC3 enforces? There's a single gate on trading. Only clients with onboarding status equals approved may trade. Every other status is blocked, regardless of ISDA, margin, product or channel. These tests prove both the allow and all the deny branches. TAC 3.1, baseline acceptance. We start with an approved client and a cash product, either equities or spot FX. Purpose, prove the happy path works before we add other rules. Expectation, order accepted. TAC 3.2, pending, to reject. Same action, but client is pending. ISDA, margin, don't matter. Expectation, rejected with a clear reason that includes onboarding status is not approved, brackets pending. Test AC 3.3, in review, reject. Client is in review, expectation, rejected, message sites in review. This shows different non-approved states are all treated as blocks. TAC 3.4, rejected, reject. Client is rejected, expectation, rejected with a reason that explicitly names rejected. This covers the strongest block state. TAC 3.5, strong control, precedence check. Client is not approved but does have ISDA equals yes and margin equals yes. We submit a derivative order. Expectation, rejected due to onboarding, proving status gate supersedes legal credit readiness. ISDA margin are validated in AC4 and AC5, but they cannot bypass AC3. Some notes here. We assert consistent machine-readable reason codes/messages so downstream teams know why an order was blocked. Channel isn't the variable here. Any channel can be used. Connectivity enforcement is covered later, AC7 and AC8. Using a cash product for the allow code isolates AC3 from derivative rules, keeping signals clear. Coverage claim. With these 5 tests, we hit all statuses: approved, pending, in review, rejected, and prove both outcomes, accept and deny, and rule precedence, fully satisfying acceptance criteria 3. Now we'll take a look at acceptance criteria 4. If ISDA signed equals no, any derivatives order is blocked. So what this rule does, if a client is approved but hasn't signed ISDA, The platform must block any derivatives trading. We keep margin agreements set to yes in these tests to isolate the ISDA gate. How we prove it? TCAC 4.1 through to test case AC 4.4, covering all four of those tests. We hit the common derivatives label one by one: futures, options, swaps, e.g. interest rate swaps, and the generic derivatives tag. In every case, the order is rejected with a clear reason like ISDA required for derivatives. Test case AC 4.5, mixed string, shows a realistic portfolio. The same client can place a cash order, for example equities, successfully, but the derivatives leg is rejected. So the rule is precise, not a blanket block on all trading. TAC 4.6, control. Flips is assigned to yes, margin is still yes, and the derivatives order is accepted, proving the rule toggles correctly. Why it matters. This prevents trading that would breach legal agreements, and the reason codes make it auditable and easy for operations/risks to resolve. For example, get ISDA in place. Another note here we have is in production, we drive this from a product taxonomy, not just keyword contains, but these tests cover the functional intent and the main labels users actually trade under. Acceptance criteria 5. If margin agreement is equal to no, leveraged products are blocked. So what this rule enforces, if a client's margin agreement equals no, they cannot trade leveraged products. We hold ISDA equals yes on these tests to isolate the margin gate from the ISDA gate we proved in AC4. How we prove it. Test cases AC 5.1 through to AC 5.3. Try the usual leveraged labels, futures, options, and swaps, and each order is rejected with a clear message like margin agreement required. TAC 5.4, mixed string, shows precision. The same client can place a cash order, for example equities, successfully, but a derivatives/leveraged leg is actually blocked. TAC 5.5, control, flips margin, yes, with ISDA already yes, and a derivative order is accepted, proving the rule toggles correctly. Why this matters. The margin is a separate legal operations control from ISDA. This prevents leveraged exposure without collateral terms in place, and the reason codes make it auditable for risk/operations. One thing to note, in production we drive leveraged off a product taxonomy/flag, not just keywords, but these tests cover the functional intent across the most common labels. Now we look at the final acceptance criteria 6. Read-only view for risk, compliance, and for sales. The purpose of AC6 guarantees that risk, compliance, and sales all have a single read-only source of truth for the 6 onboarding attributes. What we validate. TAC 6.1. Open the client details in read-only for a seeded client and confirm all 6 fields, reg classification, KYC risk, onboarding status, ISDA signed, margin agreement, connectivity, are all present and show the correct values. TAC 6.2. Change one value in the maintenance screen. For example, set KYC risk to high. Save, then reopen the read-only page. The new value must appear, proving the page is fed by the same authoritative record. TAC 6.3 to TAC 6.5. Login as risk, compliance, and sales. Each role can see the page but cannot edit it. No editable controls, and any update attempt is blocked. UI disabled, no post, no put. Why this matters? These checks ensure downstream teams are looking at consistent, auditable data without the risk of accidental change, exactly what the acceptance criteria calls for. By the end of this walkthrough, we've taken a simple onboarding story and expanded it into a complete defensible QA strategy, one that covers data quality, rule enforcement, connectivity, and audit evidence. We validated every acceptance criteria with clean, systematic tests, and we proved each gate with both positive and negative paths, onboarding status, legal agreements, margin, connectivity, and visibility. More importantly, you've seen how generative AI fits into real QA work, not as a shortcut, but as a force multiplier. Instead of spending hours enumerating fields, conditions, and decision paths, AI helps generate the initial logic model, propose full scenario matrices, and reveal branches we might have missed. My job became review, correctness, and refinement, turning minutes of AI output into test coverage that would normally take half a day or more. The result is a stronger coverage, faster delivery, and fewer blind spots across the entire risk chain. Eligibility becomes predictable, data becomes trustworthy, and onboarding moves from manual judgment to rules-driven control with clear auditability. Thanks for watching, and I hope this gave you a concrete, realistic example of how AI can boost productivity and quality in everyday QA work, especially in financial systems where completeness and precision really matter. If this reflects the kind of testing you do in your world, then you've just seen how much leverage AI can give you. If this tutorial helped, drop a like, comment, and tell me which part you want me to automate next. Spec flow, step stubs, CI wiring, or performance test seeds. I'm Scott, 7 years in QA, automation for financial systems, and I love showing how AI can save time and raise the bar on test coverage. See you in the next one.